Greetings, ACT Specialist. Commander King here with another urgent mission for you. So we've been studying gases and pressure and volume and temperature and how they're related. And that's great. So let's do something practical. I've been thinking about this. So you have a can of soda, and you know in the can of soda they pressurize carbon dioxide in it, and that's why when you open it, all that carbon dioxide fizzes out and you get that nice fizz sound. Okay, wonderful. That's great. But you might think about it from ACT's perspective if we're, let's say, transporting Coke to the moon or to Jupiter or Titan or one of our outposts on those locations. You might be concerned if there's a sudden increase in temperature, those molecules, carbon dioxide molecules, suddenly move very quickly, and before you know it, in your cargo room, where holding that Coke, something like this happens. All right, not so great, right? Okay. And you might say, well, that's not, all right, so you got a little bit Coke explosion, so you clean that up, right? But you can think about the implications of this. Let's say instead of just cans of Coke, you have cans of flammable gases because you need those flammable gases for different reasons. And suddenly, those flammable gases build up too much pressure inside. The container explodes, and now you've got just all these flammable, dangerous gases floating around your spaceship. And one wrong step, someone lights a match, or there's an electrical spark, and boom, your whole spaceship is done. So very, very dangerous stuff. So we'll be looking at Coke cans and different soda cans today, but in reality, this could have huge implications if we're not careful, because we will be transporting a lot of dangerous gases during our missions. Now, I've done some research, and I figured out that the typical Coke can currently made out of the metal it is today can withhold about 5.44 atm of pressure. And this is actually more than I thought it could withstand. So 5.44 atm of pressure, and different studies disagree, but we'll use this number because it seems like a reasonable number to use. All right. Okay, so our task today looks something like this. I want to know at different locations in space, will a Coke can explode? And some on Earth too. So let's say we take it to Mount Everest. Will that Coke can explode there? What if we take it to Venus? What's going to happen to there? Can it withhold? Will there be more than 5.44 atm of pressure built up in here? Or less, so that it won't explode. All right, and then we're going to take it to a number of other planets and places as well, because we might be transporting Coke. You know, those aliens really love Coca-Cola, and so it's a great trade good. All right, second thing, I want to know, hey, what's the max temperature I can heat the Coke can to without it exploding? Now, there are a number of different factors that we would actually consider if we were thinking about this, but I'm only concerned about the carbon dioxide for now. So let's just think about the carbon dioxide in here, all right? And so we want to avoid a situation like this on our ship. That's our main goal. Okay, and the final thing I want us to consider is I've actually designed this wonderful line of new cans and containers that can withstand more than 5.44 atm of pressure. And I want to know for these Coke cans, how high of a temperature can I heat them? And I want to put a warning label on those, right? Like, please do not heat the gases in this container to over 200 degrees Celsius or 300 degrees Celsius or whatever it may be, so that those people handling those containers know the conditions at which there'd be too much pressure and those containers burst open, and that could be really troublesome. So we want to provide good information for these people. So the implications of this are not just limited to Coke cans, especially when we transport major amounts of gases throughout our solar system. It's going to be key that we make sure that these containers stay safe, and even if we're moving into very hot environments, that they do not explode. All right. Good luck with this. I believe in you, and may the sun shine brightly upon you all. King out.